Pick up where we left off here. So we had 40 minus 26 was 14, and then there's 7 on each side makes up that 14 difference in the smaller base and the larger base. So that allows us then to set up a Pythagorean theorem where we have x squared plus 7 squared equals 20 squared. To find the missing x, the x squared plus 49 is equal to 400. Subtract 49. 351, and then 351 is divisible by 3, so I'm going to try to break that down. That's divisible by 3. So there's going to be 3 right 39. Let me take the square roots and then approximation for that. Square root of 351. 18.7. All right. Let's look at some applications of this. Okay, so a lot of times in application problems, the easiest thing to do is draw a picture of what's going on. So the roofer leaned a 16-foot ladder against a house. The base of the ladder is 5 feet from the house. How high the house does the ladder reach? Okay, so pretty common ladder length. So we got a house. Assume it's brick. There's a fancy looking brick house there, and we've leaned a ladder up against that. Here's just a ladder. And that ladder is 16 feet, and the distance that the ladder is from the base of the house is 5 feet. So what we've done is created a right triangle here. So we got the hypotenuse, the ladder, which is 16 feet, and one of the legs is 5 feet. So we have it. We're looking, how high does that go up the wall? So it'd be x squared plus 5 squared is equal to 16 squared. Set that up. So x squared plus 25 equals 256. Subtract the 25, 31. Take the square roots. Approximation of that. Square root of 231. 15.2. How we can reach the ladder set up like that. Okay. Kurt is building a rectangular deck. If the dimensions of the deck are 10 feet by 23 feet, what's the length of the diagonal of the deck? So we've got a rectangular deck, and the dimensions excuse me, are 10 feet by 23 feet. To know the length of the diagonal, would either of that line or this line, doesn't matter which one. I'm just going to stick with that one. So we have the legs of a right triangle. We're trying to find C there. So 10 squared plus 23 squared equals C squared. 100 plus 529. 629 is equal to C squared. We got the square roots. And C is going to be approximately 25.1 feet. He's stringing some lights across the top of the deck there. Seems to be a common thing to do. All right, number 12. Ashley jogged 3.4 miles east and 5.7 miles south. How far away, Ashley, is she from her starting point? So let's see. Ashley is a starting point here, and she is jogged 3.4 miles east. So east would be to the right, and then 5.7 miles south. And they want to know how far is she from her starting point. Again, we got the legs of a right triangle. You turn due east and then go due south from there. So we're going to do 3.4 squared, 5.7 squared equal to x squared. And work that out there. So 3.4 squared plus 5.7 squared. It's going to give us 44.05. Take the square roots. 63.6 or 6.63, 6.6 around one decimal place. And miles here is a good word problem, so we need dimensions out of that. Okay. Application problem number 13. A 31-foot support wire is attached to the top of a 25-foot telephone pole to a point on the ground. How far from the base of the pole does the wire meet the ground? So we have a telephone pole or power pole, whatever you want to call it there. And there's a support wire attached 25 top of that 25-foot pole. This is 31 feet. The pole is 25 feet. They want to know this. So again, we have a nice right triangle that we've created. X squared plus 25 squared is equal to 31 squared. 625, 31 squared, 961. Subtract 336. Square roots. I'm just going to go to the approximation here. Square root 336. 18.3. All right, so let's look at the converse of the Pythagorean theorem real quick and see what we can do here. All right, Pythagorean theorem's converse. So a lot of things we can figure out from the converse of here. So if a triangle has sides A, B, and C, and we go to the Pythagorean theorem, C squared, and I'm just going to turn it around a little bit here, A squared plus B squared. That's a right triangle, always. And then what happens is we can decide what kind of triangle it is based on those sides. Remember, C is always going to be the largest number, and then A and B are the legs of that. If C squared is greater than A squared plus B squared, that's going to be an obtuse triangle. And then if C squared is less than A squared plus B squared, that's going to be an acute triangle. Okay. So those things we get from the converse of the Pythagorean theorem. Okay. So if Pythagorean theorem works, then it's a right triangle. But we also get that if C squared, the largest side length, is greater than the sum of the two smaller side lengths squared, it's obtuse. If it's less than, it's acute. And so let's look at a few examples of that real quick. So we look at these three numbers. We have 3, 7. Those would be A and B, and then 9 has to be C because it's the largest number. So we look at C squared, that's 9 squared, and A squared, and B squared. That'd be 3 squared plus 7 squared. So 9 squared is 81, 3 squared is 9, 7 squared is 49, and so 9 plus 49 is equal to 58. So 81 is greater than 58, so that's an obtuse triangle. Okay. And then 20, 21, and 29. So again, we're going to look at 29 squared. That's C. Then 20 squared plus 21 squared. And so calculator help here. 29 squared, 841. And then I'm just going to do 20 squared plus 21 squared. It's also 841. So that means that's a right triangle. And then in the directions here, we also see that first determine if the three side lengths could form a triangle. The sum of two smaller sides must be greater than the third side. That's the triangle sum theorem for sides. So we look at these two here. 3 plus 7 is 10. That's bigger than 9. 21 plus 20 is bigger than 29. So those things can happen. If we look at number 3, though, 4 plus 11 is 15. That's not bigger than 16. So this is not even a triangle. On number 4, 17 and 17 34, which is bigger than 22. So that is a triangle. So we're going to test it with the converse of the Pythagorean theorem. So 22 squared, and then 17 squared plus 17 squared. So 22 squared, 484, 17 squared plus 17 squared, 578. So 484 is less than 578. So that is an acute triangle. Okay. So again, the test, if it is a triangle to begin with, you take the two smaller sides, don't square them, and just add them together and compare that to the larger side. If the sum of the two smaller sides is bigger than the third side, then it is a triangle. And then you check it with the converse of Pythagorean theorem. We looked at number 5 here. We can do just a couple more here. 18, 24, and 30. 18 plus 24 is bigger than 30, so we know that that is a triangle. So 30 squared, how does it compare to 18 squared plus 24 squared? It's going to be 900, I know that. And then 18 squared plus 24 squared is 900 as well. So those are equal, so that's a right triangle. Number 6, 8 plus 15 is 23. That is not bigger than 23, so that's not a triangle. So we don't have to worry about that one. Number 7, 31 plus 35 is obviously bigger than 39, so we're going to do the Pythagorean theorem. How does this work out here? So 39 squared, 1521, and then 31 squared plus 35 squared is 2186. That's less than, so that's an acute triangle. One last one. 11 and 19 would be 30. That is bigger than 28, so this is a triangle. So we're going to set up 28 squared and then 11 squared plus 19 squared. 28 squared 28 squared, 784. 11 squared plus 19 squared, 482. That would be obtuse because c squared is larger. So that's the converse of the Pythagorean theorem.